Welcome back, boys and girls. Unit 2, Module 5, adding, subtracting, multiplying, and dividing decimals. I'll call this part 2 only because we're going to do 6 through 10. So let's get it started. Shane measured a piece of construction paper to be 2 55/100ths of an inch wide by 5 1/10 inches long. What is the area of the piece of construction paper in square inches? So, keyword here, area. In order to get the area, we have to take the width times the length. So that means we need to multiply. Here we go. So we have 2 55/100ths times 5 1/10 and multiply. 5 times 1 is 5. Again, 5 times 1 is 5. 2 times 1 is 2. We have our placeholder 0. 5 times 5 is 25. Again, 5 times 5 is 25 plus 2 is 27. And 5 times 2 is 10. Plus 2 is 12. Add it up. And don't forget to count back the amount of places behind the decimal. 2 here, 1 here. 2 plus 1 is 3. Once, twice, 3 times. So we have 13 5/1000ths. So does that make sense? Well, let's estimate. Let's say 2 55/100ths. Let's say that rounds up to about 3. 3 times 5 would be about 15. Yeah, this makes sense. So the area equals 13 5/1000ths inches squared, because we multiplied a length by a width. Our answer is in square units. And that's the piece of the construction paper. Next up, we have Connor bought 15 pencils at 45 cents each. Mara bought 30 pencils at the same price, the 45 cents each. How much more did Mara spend? Well, we have to find out. Well, it's telling us here that Mara spent more, so we have to find out how much Mara spent and then subtract that from what Connor spent and to see how much more Mara spent. So here we go. Here's Connor. Let's do 45/100ths or 45 cents times 15. So this will be for Connor. And then we'll do Mara as well. So we can do 45 cents times 30 pencils. Yes, you can put your 0 if you'd like to, but it doesn't change the value. Whether you put 0 holes or nothing at all, doesn't matter here. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. 5 times 1 is 5. 4 times 1 is 4. We'll add it up. So it wouldn't make sense for it to be $675. We have to remember coming back twice because there's 2 numbers to the right of that decimal. Bring it back in your answer. Once, I'll even show it once, twice. So my answer is $6.75 for Connor. And here's Mara. Placeholder 0. 5 times 3 is 15. 4 times 3 is 12, plus 1 is 13. And we'll just add that up. Obviously, 1,350 wouldn't make sense because it was only 45 cents each. We have 2 numbers in back of the decimal here, so we're going to bring it back once and twice. So now what is our answer for Mara? $13.50. So now we need to find out how much more. It tells us to subtract. How much more money did Mara spend? So we're going to subtract. When you add or subtract decimals, we have to remember to, that's right, line them up. So we're going to get the difference between Mara and Connor. We're going to regroup. 10 minus 5 is 5. Can't do 4 minus 7, so we'll do it again. So now we have 14 minus 7, which is 7. 2 minus 6, can't do that either. So now we have 12 minus 6, which is $6.75 that Mara spent more. Just to label it, more money spent by Mara. And there you go. Next up, we have Colin. Colin earned $102 raking leaves. He worked 3.5 hours yesterday and 5 hours today. How much did he earn per hour? So it's a two-part question. We have to figure out how many hours he worked first. So it looks like he worked 3.5 hours yesterday, 5 hours today. When we add our decimals, we have to remember to line up our decimal. There's no decimal here, but it's understood to be 5 hours, so that we have to put it in the right place value position before we add. 5 plus nothing, or if you want to put your 0, that's fine. 5 plus nothing is 5. 3 plus 5 is 8. Don't forget to align your decimals when you're adding or subtracting. There we go. We have 8.5 hours over the last 2 days. So he's earned $102 raking them. And we're going to find out now, how much did he earn per hour? We're going to divide that by 8.5. Now, we have a decimal in the divisor. We're not allowed to divide until we make this a whole number. So whatever you do in the divisor, you also have to do in the dividend. Add a 0 in this case. So now we have 85. By rewriting it, 85 into 1020. How many times does 85 go into 102? That's once. You subtract 85 from 102. 12 minus 5, well, let's appropriately do this. So you had 10, 9, okay. 12 minus 5 is 7. 9 minus 8 is 1. Bring down your 0. How many times does 85 go into 170? Well, a little bit of side work you may need to do just to test it. Well, 85 times 2 is, there it is, 170. So we're going to put our 2 down, subtract 170, and no remainder. So how much did he earn per hour? $12 per hour. Moving along, we have Amory drives 100 miles in 1 hour. How many miles does he drive in 2.5 hours? Based on the statements, we have to answer this question. So Ben drove, well, this should say, the argument, all right, based on the statement above, select the argument you agree with. So, well, let's do this out. If Amory drives 100 miles in 1 hour, how many miles does he drive in 2.5 hours? Well, that's simply 100 times 2.5. There's many different ways you can solve this. I'm just showing a possible way you can do it. There are easier methods to do it, but you can do whatever you feel comfortable with. I'm just showing the work just in case you like to. Now, I see there's a decimal in the divisor and in the problem, so one number is to the right of the decimal here, so we're going to come back once in our answer. So now we have the answer of 250. So, looking at our answers, Ben says he drove 200 miles, Martin says he drove 250, and Anna says he drove 25,000 miles. So, it looks like Martin would be the correct answer. Last but not least, we have Very made $100 doing chores. She makes $9 an hour. How many hours did she work doing her chores? And here we go. So, which equation could be used to solve this problem? Select yes or no for each. Could this problem work if we did 100 divided by 9? Would that give us how many hours did she work doing her chores? Sure. You can't do $9 divided by 100 here because that wouldn't make sense. 9 times something that made 100? Sure, because that's the inverse operation here of 100 divided by 9. And something times 100 equals $9. That's not going to give us how many hours did she work. And of course, you can always show your work here too. So if you choose to do it out, 100 divided by 9, well, that's going to go in one time. Should be 9. You subtract, bring down, and it goes in again. So about looks like about how many hours did she work doing chores? About 11 hours looks like it if you were to actually do it out. But it's not necessary in this problem because it's asking us which equations could be used to solve this problem. And that's a wrap. Thanks for watching, and the other part should be up soon.